All right, this is chapter 6, linear relations. So we're basically just continuing where we left off in chapter 5. And a new term that we're going to talk about here, I'll just make a note for myself, um, is slope. Okay, rate of change is now going to be called slope. So if you have this booklet, I would, in the middle, slope is the word that you want to look for, and the letter we use is M. Okay, slope is M. So that's like the central idea. Slope, it will allow us to find a lot of different things. It will allow us to find different points on the graph. Um, and it is also known, I will say that, also known as the rate of change, right? Except for rate of change is used more for word problems when there's a context around it. Slope is just linear graphs. We're just talking about linear graphs and slope, even though we are gonna uh, add some context to it as well. So the first thing that the slope tells us about a line is the steepness, right? Steepness of line, it will tell us, or steepness of roof, as you will see in a minute. That is that. So whether a line is steep or not so steep, right? It could go either way, okay, increasing or decreasing, or then you have a shallow line like this, right? It will tell like the value we get, right? The value we get from the slope will tell us the steepness of the line. So we'll circle that. That's kind of like it branches off into it. It is also, it will also allow us to find, I'm going to put that here and then an arrow after, um, allows us to find more points on graph. And you know how we found the third point earlier using, we would pick a random x value. This will allow us to do that faster. Okay, so it will allow us to find different points on the graph. Okay, and it also, we know that it stays constant um, regardless of which 2 points are chosen. Okay, so it doesn't matter which 2 points you choose on the line, you will always end up with the same slope. Sometimes it won't look like it right off the bat, but if you reduce that fraction, you will get. So remember, slope is rise over run. Okay, and here I will add here, it is the rise. So slope will sometimes be referred to as rise over run. Okay, and think about it, which is the same thing as delta y, right? Your change in y is called a rise, even though sometimes we'll be dropping, we still refer to as the rise. It's the change in y, and the run is the horizontal, and that would be your x, right? So uh, slope should be, you should know that m is the letter we use for slope, that we will sometimes refer to as the rise, which is the difference in y, over the run, which is the difference in x, right? And so slope, because of this, ends up being this. This is the calculation method of the slope. right? So we circle that. It's also slope. So all of these things are connected to slope, okay? I will tell you that there are 4 types of slopes. 4 types of unique slopes in general, okay? You have a positive slope. So if you calculate the slope and you get a positive number, you know that the line is going to be increasing from left to right, okay? Um, and vice versa. If you see that the line is going up from left to right, you are expecting a positive slope, right? They go hand in hand. You have a negative slope, and that one will be decreasing from left to right. You have a 0 slope. We'll talk about these more later on. And when you have no slope, you're living in Manitoba, right? We have next to nothing. It's flat, right? So there's a 0 slope, okay? Where m is going to be equal to 0, of course. Here, slope is going to be negative, and here slope is going to be a positive value. We don't know exactly the value, but we do know that. And then we have an undefined slope. And that's a vertical line, okay? And so we just say that's it. We just talk about an undefined slope. Another thing I want you to remember is that when you have a 0 slope, the equation of that line, it's just a horizontal line, is going to be, in particular, y is equal to a number. That will make more sense to you later, but right now, y is equal to a number, that's a horizontal line. So it's good to have this right up front page, have all of these things there, okay? When you have an undefined slope, the equation of that line will be x is equal to a number, okay? So vertical, it will be quite simply x is equal to a number. When you have a horizontal line, it's just going to be y equals to a number. There's only one variable. There's just a y in this case and just an x. There's not both variables in the mix. Both of these will be diagonal lines and they will have both variables in their equation. Okay, so 4 types of slopes. We'll also circle this. This is a bigger circle, right? But that's also something I want you to keep in mind all the time. And here is Mr. Slope. If you like this, go for it. So if you have a positive slope, the line is going up. If you have a negative slope, the line is going down. If you have a horizontal line, the slope is 0. And a vertical line, the slope is undefined. Okay. And there you have Mr. Slope. Okay. To help you remember, whatever it takes. All right. Another and last thing, you can use the counting method, I call it, determine slope. Okay, you can use the counting method to determine the slope. So what do I mean by that? Well, if you have a line, okay, and there are 2 points here, you can say, okay, I know that my slope is rise and run. So you can say, I'm going to count how many steps I'm rising, and then I'm going to count how many steps I'm running. Right, so this is your rise and your run. And then it's be like, okay, I rose 1, 2, 3, 4, right? And I ran 1, 2, 3, 4 as well, coincidentally, right? And it's positive because it's going up, it's increasing from left to right, so it's just that. So my slope is really just 1, a slope of 1. So that's the counting method. Sometimes if I don't ask you to calculate that, you can just do it that way, and that's fine. So a lot of stuff here. Front page. I think that's all I'm going to say for now. I just want you to have this in mind as we move along this unit, right? I like to have that right up front there. Okay. Um, there's one more that I'm thinking of right now. Like maybe that would be good to add. Yes, I will definitely add that. Um, it also, if you have two lines, tells us if lines are parallel, that's the, or perpendicular. Okay, if they meet at a 90. That's I promise that's it, right? I hope you have enough room. If not, just make the bubble somewhere out here and then make the arrow go out to it. And so that's slope. Slope is the center of everything we're doing, but it will show up in other things. So just keep that in mind, okay? All right, let's keep going. The steepness of a roof or ramp is measured by calculating its slope, okay? And remember, slope, right, is essentially rise and run. Most applications will just say, hey, we'll just do rise and run, okay? Especially when it's not on a coordinate grid, then we'll just do rise and run. Which ramp is the steepest? So the greater the value of m, the steeper the line. The line segment or the line or the roof or the ramp or your driveway, it doesn't matter, okay? So we have, in this particular case, if you wanted to know how steep this segment is, okay, if you wanted to describe and say, this is how steep it is, this is what we would do. So it's not a point on this anywhere, it's just the steepness, okay? We would say rise divided by run. And in this case, this is your rise here, and this would be your run, right? So the slope is 6, and they're both in meters, so we can just ignore that because they will cancel out. Slope is 1/2. Just leave it like that. Leave it as a fraction. You can turn it into a decimal if you want. Sometimes that's convenient. Right now, we're just going to leave it like that. And then here's slope. This would be the rise, and this would be the run. So it's 12 over 6. So slope is quite easily, it's just 2. And there are no units attached to it. Okay, it's just 2. It's just 1/2 because the units cancel out, right? And then here you have rise and run, and it's 12 over 12. So m is just 1. So by observation, we could tell that this one is the steepest by observation. But let's say this was not provided to you. All you have is to go by the actual values of the slope. And this is the steepest ramp in this case. Okay, the greater the value, the steeper the ramp. Okay? So that's how you do a question like this. It could be that they're just giving you the rise and the run of the various ramps, and you just have to figure it out. And this is how you do it. Okay. Consider the following lines. Um, so what we're going to do is we're going to find the, in this case, we're going to find a slope using the formula because we actually have, right, this is 1, 3, and this is 2, 5. So to calculate it, this is what we do. And so you go y2 minus y1, sorry, over x2 minus x1, and that is 2 over 1, which is just 2. Positive, I will add on this particular case. Okay. All increasing lines have positive slopes. You always go left to right. That's how you know for sure. If you're not sure, start from the left. Yeah, this one is going up. So this is a positive 2 slope. Now, bear with me here. Let's back up to this point. 2, 1. The top, this number here represents the rise of this particular line, and this is the run. Remember how I made you describe it's rising this much over this much in terms of your x? Well, here you're saying that you're rising 2 units for every 1 unit of run, okay, on this line. That's technically what's happening here. So let's put that to the test. Let's start over here. This particular point is -2, -3. Okay? -2, -3. That's a point on the line that I can easily identify. Let's try that. If you go up, I'm going to use the different color. If you go up to, so 1, 2, and then run 1 unit, okay, you get to the next point on the line, okay? And so this particular point here is going to be -1, -1, okay? And let's keep going. I'm not going to do the waves. I'm just going to go from here up to over 1. Do I land on the line again? Yes, I do. Okay. And that continues up to over 1. And so the saga continues, right? So it's always consistent. The slope, the steepness is consistent no matter what. I could have picked this 2, 5 up here, out here, I mean, and this over here, and I would still end up with a slope of 2. Let's put that to the test. Let's write them down. -2, -3, and 2, 5. This is x1, y1, x2, y2. I encourage you to do this the same because you're going to end up with having to deal with negatives, right? y2 is 5 minus, that's the formula, y1 is -3. So watch the double negatives, over x2 minus -2. So the minus is part of your formula, and if the value you're taking happens to be negative, it needs to follow, right? So we know that these two turn positive and these two also turn positive. So you end up, why do I have y here? Sorry folks, it's supposed to be m. Too excited. Okay, 5 plus 3 is 8. 2 plus 2 is 4. You go 8 divided by 4 is still 2. There is your slope here and here. You both have a slope of +2. So you know it's increasing. and there'll be a positive slope there. Okay. I will go a little further. I apologize for that. But let's write these points down here. -2, -3. Ordered pairs, right? And then I go -1, -1. And then I go, this point right here was 0, 1. And then I was at 1, 3. And then I was at 2, 5. Okay. You can see, let's check, remember the checking if it's linear, right? This is +2, +2, +2, +2. Consistently going up by 2. So this is your rise, which, right? Which is 2. And what about the run? This is +1, +1, +1, +1. So you can see that your slope is actually here. It's consistent. That's what you were doing, right? This is your run and this is your rise. So the rise is consistent and the run is consistent. That means that this is actually a straight line, okay? So from graph, we calculated our slope using 2 points that were right close to each other, and then we figured out the slope 2 points that were a little further apart, and we came up with the same conclusion. And we concluded that when from left to right the line is increasing, then you have positive slopes. Okay. Next, we have -2, 3. Let's write those points down, and this one here is 1, -1. Okay, and we will find a slope. Let's make this our x1, y1, and this the x2, y2. Okay, and so the slope would be -1 minus, so right, y2 minus y1 over x2 minus x1, which happens to be -2. So watch the double negative. The negative that I write down first comes from the formula, and then the value, if it is negative as well, make sure you put it in brackets, and then point out the fact that they will be positive. And so -1 and -3 is -4 over 1 plus 2 is 3. This is a negative slope, which we expected, right? So all decreasing lines have negative slopes, and that's also from left to right. Okay, so you guaranteed that. Let's do something a little different here now. Let's start with this point. Remember I told you you can use the slope to find more points? Well, that's exactly what we're going to do. So if you start with -2, 3, right? That was one of the points on there. How can I use the slope to find more points? Well, this is my rise, and this is the run, remember. This will affect the y value, and this will affect the x value. And notice what the sign is. I always make the sign float up, and then you can't go wrong. So if the rise is -4, that means that from here to your next point, you'll have to go -4. So 3 minus 4 is -1. And the run is +3 here. So -2 plus 3 is 1. That's another point. Wait a minute. Yes, I identified it anyways, right? Can I find more points, Mr. Jerkson? Absolutely. You keep going, right? -4. So -1 minus 4 is -5. And then we have to add 3 here. So that'd be 4, -5. So if you were at 4, you'd be at -5 here, which, look, It fits perfectly. Okay. And you can continue on forever. So notice that the slope, I always make the negative float up, and that negative sticks to one of the values only. You don't make both negative, because then it's actually a positive slope, which means that the line will be going up. So I made the 4 negative, so it drops by 4, even though we call it rise, and the x value is affected by +3 because there's a plus there. Okay, so we'll continue. Consider the lines to the right. Which line or lines have positive slopes and which ones have negative slopes? Maybe pause here and see if you can already figure it out. Okay, so positive slopes, right? I'm going to identify from left to right. This one is positive. This one is positive. Okay, so A and B, line A and line B. And then I have my negative slopes. And from left to right, this would be negative, and this would be negative. Okay, so line C and D. Line C and line D. There we go. Here is again horizontal lines. I will explain it a bit more here. Horizontal lines have no rise. Okay, that's the key here. Therefore, slope would be 0 over, it could be any number. Whatever the run is, it wouldn't matter. Okay? And that would result in 0. Whenever the numerator is 0, the whole thing is 0. Okay? Their slope is always 0. Okay? Horizontal lines, the slope. And the equation of such line looks like this: y is equal to a number. Okay, so we'll actually cross the y-axis at that value. So if it's y is equal to 2, it will be a horizontal line going through y is equal to 2. Okay. Next, we have vertical lines. Vertical lines have no run, right? Therefore, the slope of such line would be, right, you would calculate, it would have some kind of a run, of a rise, right, because it's going up and down, but the run would be 0, and this is undefined. Don't say it's equal to undefined, just say it's undefined. Because watch, I can take any number, 2 divided by 0, let's say, and you get a math error, like you can't do it, right? So that's the, you cannot divide by 0. So their slope is always undefined. Equation looks like this: x is equal to a number. Okay, keep that in mind. That'll be handy later. Trust me. Okay. Okay. The Determine the slope of the line that passes through 2 points. So now we're going to find the slope just from 2 points. Okay, you can figure out from 2 points, and this is how you do it. You've done it all the time, all along so far, right? The key here is stick with, label them correctly. So stick with what you're labeling them with. So if you want to go x1, y1, and then go x2, y2, that's what you do. Okay. And so there's no other way other than just calculating this, right? So we go y2 minus y1 over x2 minus x1, and that'd be 5 minus -3. There it is again. And then it's 4. Oh, wait, this is -1. y2 minus y1, x2 minus x1. This turns positive. And so this is 5 plus 1, which is 6. 4 plus 3, which is 7. So we have 6 over 7 as our slope. And remember, this would be the rise of this for every 7 units of run. Okay, you want to try to simplify it if possible. Okay, in this case we can't. Determine the slope of the line that passes through point A and has a y-intercept of 6. This is a hidden point. Okay, so really the y-intercept of 6 is really a point where x is equal to 0, right, and y is equal to 6. So there are your 2 points. So x1, y1, x2, y2. And so my slope is 6 minus 4, and then it's 0 minus 1. 6 minus 4 is 2, 0 minus 1 is -1, so the slope is -2. Okay, and let's graph these now. Like here you have a point A is 4, 5, so 4, 5 is up here, and -3, -1 is here. Okay, so let's graph that. To hurry a little bit because the bell is about to go here. I have a different class. So that's the line. We don't know what the equation is yet, right? But that's the point. So this would be A, right? And then for B, we actually have everything we need to come up with the equation for B because we touched on it at the end of chapter 5. 0, 6 is here, and we have a slope of negative, or A is 1, 4, sorry, 1, 4 is right here. So you can basically just pick those 2 points and graph it, right? But what if I asked you to find a third point? So you've got that point, this point. How could you find another point? Third point, we start with 1, 4. Or let's start with 0, 6. My slope is -2 over 1. I always like the negative to float up. So that means that this one will go down by 2 to 4, and this one will go up by +1. So it's 1, 4 I already have. If we do another one, sorry there, that'd be 2 plus 1 would be 2, 2. So you've now come up with another point. So 2 2's right there, which you can see lines up perfectly. And we just connect the dots there. Okay. So this is line B, right? 6, draw a line through -2, 4, and it has a slope of 1/2. And notice that it's positive. This is the rise. This is the run. This affects your x values. This affects your y values. Okay, so I might stop it and then do another video for this if I have to. So we start at -2, 4, right there. That's that point. And then we use a slope of rise of 1, run of 2, put a dot down. Rise of 1, run of 2, put a dot down. And that's how you graph that particular line. There's your 3 points. Okay, I will stop it here and maybe make another video here for that. But the homework, I'll write it down quickly. 339, 5 to 9, 11 to 13, 17, 19, 23, 24, 26. Okay?